Okay, hello everyone. My name is Kimi Mattila. I work here at CSC as an application specialist, helping CSC users to use our computing facilities. And today I'm going to tell you about the new Allas-object storage service, which has been taking use at CSC, and how to use that for migrating your data from Taito to away from Taito, which will be closed pretty soon. There is a chat window here, so that if you want to ask some questions, please type them in the chat, and we try to locate them and then answer them. I don't know if we are going to answer questions immediately or not. Depends a little bit on the question. At least in the end of the session, we can go through them. But you can ask already now, and if it's somehow related to the topic I'm just discussing, then we can skip to that and discuss about that. But let's get started. This presentation is the second Allas webinar, and this is not a kind of sequel. We are mostly covering the same stuff as in the last week when we had the first Allas object storage webinar, but things have evolved actually in 1 week, so this is not completely the same webinar that it was on the last week. But let's check the situation right now. So first of all, what is this Allas thing? CSC has purchased or taken in use. CSC is taking in use several new hardware components to our environment, and the Puhti cluster environment is already replacing the Taito cluster. Puhti supercomputer is coming on later on next year, and then we have this Allas storage area, which is something which we haven't had before at CSC at all. So this is a place for storing data. This is not a computing server or some kind of disk area, but the object storage-based service for storing your data. And it is meant for to serve the CSC computing projects and other projects at CSC. So it's the place where you should keep your data during the lifetime of the CSC project. The default quota for each project is 10 terabytes. But you can get more if needed. And CSC has already previously had things like HPC archive or other services where you can upload and download data from the CSC computing environment. But what's new in Allas is that it's no longer the usage of the Allas is no longer limited only to the CSC computing environment, but you can also access this same service from actually anywhere from the internet. We have the clients available in Taito and Puhti, and it will become in Puhti too, but you can also use it in other places too. The total capacity of the system is 12 petabytes. If you take from the technical point of view, it's an object storage-based system based on Ceph hardware, and it's a kind of a secure storage place in a technical sense, that when you put some data to the system, it is stored as an object, and not just as a one copy, but actually multiple copies of the data set is stored in the system. So it's technically quite robust. If something breaks in the system, we probably have 1 or 2 copies still of the data set available somewhere in the system, and you don't even notice that we have replaced some disk on some service there, some service there behind. However, you should notice that this is not a backup service. See, this means that you are still mastering the data here, and the data set you have there is, from the user point of view, the only copy of the data set. So if a user accidentally deletes or overwrites some data, it is lost. We don't have a kind of other copies of the data available in that sense, that you could come and ask from CSC that, could you please return this file to my home directory because I accidentally, to my Allas environment because I accidentally overwrite it or deleted it. It's not possible. Once you delete or overwrite the data, it's gone, and you cannot kind of keep backups for you. However, you can use yourself this Allas storage system to create your own backupping system, so that you have several places in Allas where you have different time-step copies of your dataset, but you have to build this system yourself. There are some tools in the Allas toolkits, which I'm actually not going to discuss in this session, which you can use to create these kind of services yourself, but it's then anyhow up to the user or the users to create this service. CSC is not providing this kind of backupping service for Allas or in any other disk environment at CSC at the moment. Another issue here in Allas is that it is an object storage system, meaning that the data is stored as an immutable object in the system. So it is just stored there, and if you want to do something with the data, you have to read it to some other place, to CSC computing environment or to your local computer or somewhere else, and then see what is inside the data, modify it, and if you need to store a new version or new copy of the data, then you have to push it back to Allas environment. We have a rich set of tools for managing the data. They are mostly based on S3 and Swift protocols, which I will be discussing later on more. This I mostly already covered, that you can access this service directly from your own computer as well as from the supercomputers of CSC. And the data must be always copied to the place where it's used. What's nice also here that you can also publish your data here to the internet, so that it can be accessed through URL address, so that anyone who has the URL you create to this environment can then read the data. So this makes a kind of this makes sharing of the data very easy. Something about terminology related to Allas and object storage in general. The hierarchical, the structure of the object storage system from the data management point of view is very simple. They are kind of basic storage. First of all, each project gets its own storage quota, which is by default is 10 terabytes, but you can apply for more. So this is Allas is the place where we hope that if you have a data set that you need to store somewhere, that this is the first place where you put it while you are still working with the data. So in the CSC computing environment, we at the moment don't have any other kind of permanent or semi-permanent storage places for your data. In Puhti, we don't have a thing like project directory anymore. So you should use this Allas to store any data that you need to preserve for longer than the 90 days, what is the storage time in the Puhti and Mahti areas. And as I said, the data is given for a project. It's not given for an individual user or specific users, but for a project. But of course, you can have several projects, and you can have projects where you are the only user. But anyhow, this system always deals usage and users and the data quotas on the level of projects. So it doesn't separate between the different users. And then inside this quota that has been granted to your project, you can create things called buckets. They are kind of the root directories or root folders of your data. And each project can have up to 1,000 buckets here in Allas. And there's no kind of hierarchy in these buckets. So you just create low-level buckets and then put objects inside them. And there's no kind of sub-buckets or directories inside these things, but just a kind of these basic data containers called buckets where you have data preserved as things called objects. Each of the buckets can have up to 1 million objects inside there. And these objects that you put into these buckets can contain any data. It's a kind of a static immutable data set that you put there. Typically, the system is so that one object is one file, but it's not necessarily so, and it's often not reasonable to do it so that each file would be stored in a single object, but you can do so. And that's a kind of the level that the buckets are the root directories, and then you store the data there as objects, so that the object corresponds to a kind of file. The buckets can, or the object names can contain slashes which make the object name to look like a directory path, and many applications can then kind of mimic the system so that it looks like you would have a directory structure. But that always depends on the application that you are using. Really, there is no directory structure inside the system, but the object names are just such that they may look like a directory structure. The buckets can have some metadata, the objects can have some metadata, and you can manage it that way. Important thing to notice here is that these bucket names are used when you are publishing your data in the URL address that you are going to have for your dataset, and because of that, each bucket must have a unique name throughout the whole Allas system. So not just in your project, but in general. So as I have already created a bucket called bio to this system, no one else can no longer create this bucket here anymore. And because of that, when you are starting to build your system here, keep in mind that it should be good to have some kind of a project or personal identifier in the bucket name, so that you can be sure that no one else is going to create the bucket that you need with the kind of reserve the name that you plan to use. So that it's good to have your project number there in the bucket name, so you can be sure that no one else is going to use this same name, and you can start building your dataset system and being quite sure about that that your bucket names that you're going to create in the future are not conflicting with other users here. How to get access to this Allas system? Well, if you are not a new CSC user, you have to first register to CSC, set up a project at CSC, and for the project you need to have a person called principal investigator, who is kind of the responsible person for this project. And then you have to apply for the Allas service. Most of the users, most of you, if you are already using Taito, you have done these steps 1 and 2. So you have a CSC account and you are belonging to some computing project at CSC. You may be the principal investigator or not, but anyhow, you are within a computing project. Now you should notice that even though you are an old CSC user, you still have to apply for the Allas service as well as for the POTA service. So they don't come automatically for your project. Your project PI must go to the Taito.csc.fi portal and apply there for access to Allas and POTA services. The PI can also add new users there. Typically, your project members are already added to your project, so it's enough that the PI goes there and applies for access to Allas and Puhti. But notice that also, if you are just a user in your project, you still have to go to My CSC service and accept that you are going to start using Puhti and Allas. So it's not, you also have to act here. And I can actually quickly interrupt this sharing of the slides and show you quickly what does the My CSC environment look like. So here is My CSC telling you who you are and what projects you have at CSC. You click to My Projects list and you can have here one or more projects. And for example, here I have one project which was just started, this one. And when I choose the project, I see the information there. And here is the list of services for the project. And for example, for this project, I can see that here are these bells. I'm not the PI of this project, but this project has applied access to Allas and Puhti and CPOTA. But I'm not able to use Allas yet in this project because I haven't accepted Allas yet. But now I can accept it, and after this only, I can start using Allas. So this is what all the users have to do before they can start using Allas. And let's continue the slideshow. Then, okay. So then you have access to Allas. And as I already mentioned, the quota and the storage space and the system is granted for the project members. And there's actually no kind of a separation between project members here. All project members can read and write and delete any data that is in the project area there. And the objects actually don't even have any sign of who has been importing or exporting or modifying these objects. They just are there, and they know that they are managed by somebody who belongs to the project. But there's no kind of by default any kind of user settings like in the Unix environment, which would specify that who is able to do something for the objects which are there in the system. So all the project members have similar access to the data. Then how do you use this Allas? From a technical point of view, Allas supports two protocols. It speaks two languages, which are called S3 and Swift. These both can be used, and if you have any tool which kind of understands either Swift protocol or S3 protocol, it can probably interact with Allas. At CSC, the S3 protocol is used by S3 CMD command, while Swift is used by Swift protocol is used by several tools. For example, the native Swift client, rclone, atools, and cyberduck. rclone and atools we are soon going to demonstrate a little bit more. And what's the difference between these protocols is that, first of all, the way how you authenticate when you are using Allas is different. S3 is based on the permanent keys. So it's enough that you once create this pair of keys and have them in any of the systems that you want to, that way you want to use Allas. And then when you have these keys available and S3 compatible tool there in your environment, you can access Allas always. The connection is kind of always open until you delete the keys from the system. It's nice and easy, but it's a little bit unsecure, especially in the cases like in Puhti or Taito, where you are working in a multi-user machine, where if somebody sneaks in and cracks the machine, then this person can, if he or she can go to the home directories of the users, then the keys are there and the user can continue directly to the Allas environment of this same user too. The Swift is based on the Swift authentication is based on temporary tokens. So you do an initialization command, give your password, and then you have a connection to Allas which is open for 8 hours. And after every 8 hours, you have to kind of reopen the connection. So this is more secure. You will not have open connections to Allas if you are not actively working for it there. So it's in that sense more secure, but of course it causes some problems when you have to refresh the connection every now and then. Also, these two protocols handle metadata different ways. So if you have created some metadata with Swift to your object which you have stored to Allas, you cannot read the same metadata with the S3-based tools. And also larger files, especially the files over 5 gigabytes, they are split into smaller pieces when you upload them to Allas. Actually, for the end user, it doesn't show at all normally in normal everyday use, because you will have this kind of front object which points out to the pieces inside Allas system, and then when you ask the data back, it's automatically collected from the pieces to you. However, Swift and S3 does this splitting in a little bit different ways. So you cannot rely that if you have uploaded a large data set to Allas using Swift, that you cannot download it. It's not sure that you can download it with S3 and vice versa. So if you start using one of these protocols, you should continue using it in the project where you are handling with the data. So S3 is mostly, or S3 is good in cases where you are using Allas from, say, your permanent own server or from virtual machine running in cPOTA, where you have just a single user machine which is conducting Allas all the time. While Swift is better when you are using Allas from the CSC computing environment or otherwise doing kind of interactive usage of this Allas environment. And then, yes, so topic of this seminar actually is moving data from Taito to Puhti, because Taito will be closed. And now we are proposing at CSC that you should do the movement through Allas system. So if you have some data here in the work directory of Taito or in the project directory of Taito, you should now start pushing them away, because Taito will be closed pretty soon. And the way we recommend you to do it is that push this data from Taito to your storage area in Allas. And why to do that instead of just pushing the data directly to the Puhti, where you are going to continue working with your data? Now the difference is that in Taito you had this work directory, and actually there you had the nice do not remove directory where you could keep your data for a longer time, and then you might have a project directory where you could have something up to 100 terabytes of data permanently available in the computing environment here. Now in Puhti we won't have this kind of services available. The only kind of main place where you work with your data is the scratch area in Puhti. By default you have only 1 terabyte of space there, but you can apply for more. And that's the place where you should manage your large dataset, but this is not a permanent storage place. The data is cleaned if you haven't been used it for 90 days. And no, you cannot apply project directory to Puhti. We are not creating them. You have a small permanent project application area where you can do your own software installations and maybe put some minor datasets there, but not anything big. And the idea in the future is that that in the future, when you are working with Puhti, you have the main copy of the data here in Allas, and then when you start working with your dataset, you pull it to Puhti and then continue working there, maybe some weeks or months, not anyhow longer than 3 months at a time, without doing a copy back to Allas. So you are not preserving data here for a longer time than just a few weeks at a time, and then you push it back to Allas environment, and when you read the data again, when you need the data again, you read it back to Puhti. So that's why it's not worthwhile pushing the data from Taito directly to Puhti, because you will anyhow need to have a copy of your important data into Allas. So it's easier to push it right away to Allas and then pull it to Puhti from Allas once it's uploaded here, and that's how you do the transportation of the data. Well, this sounds a kind of little bit more difficult than what it used to be, but the nice thing is in Allas is that, as we already discussed, that once you have pushed the data from Puhti or Taito to Allas, it is actually accessible to nearly everywhere. You can then use the data from your university server or virtual machine in Cpota or in your laptop or even from your cell phone. And also these things can also add new data to Allas. So you can have some kind of lab somewhere where you have a permanent connection or some semi-permanent connection that pushes the new data sets to Allas, which you can then use to work with the data either in the CSC environment, locally environment, or some other university. So this is a kind of, in that sense, nice data hub which you can use to collect your research data and use it wherever you need to use it. How do you then use it? We already discussed about the CSC environment, so that in Puhti and Taito we have these command line clients available, rclone, Swift, S3, CMD, and A-tools. But there are other ways to use this service also. In virtual machines, you can set up a kind of virtual disk mounts with Fuse environment or use these same tools there. And in the laptops, you can use these tools through graphical user interfaces like CyberDuck, or then I will soon show you the POTA web interface, which is also a kind of graphical interface to Allas area. At Puhti and Taito, how you get started here is that, okay, you first do this thing that you apply for Allas access in my.csc.fi and make sure that you have it available for you, and then to set up the environment, you run command first moduload Allas in Puhti or Taito, and then run command allas-conf, where you define which project you are using and open the connection for 8 hours. And then take a look in the manual, which is there in the Taito.csc.fi, to see how do you actually work with the Allas, because we haven't here time to study all the details that are available for you. There's a question. Okay, I have to put my glasses on to see it. Is the data transferred to Allas and readable in a readable format that can be downloaded to a computer and open it and used normally? Yes, in principle. It depends how you do the transformation, but it doesn't actually. The idea is that you put the data to Allas in some format, and it's the same format which you can use anywhere. So if you put the data there as a say an image file, it is an image file. If you put there a text file, it's a text file. The standard format is Z compression, which is done with APUT, and that's also kind of just one of the formats, and I will come to that issue just in a moment. So there are two tools which we are now showing here in this webinar, and the first tool is rclone, which is a kind of a power user, easy to use and very effective command line tool to put data into Allas and get data from Allas. It's available for Linux and Mac, and in some cases, some ways also to Windows, so you can also use it from your local Linux or Mac machine. And it's very nice, effective, have many features. But what's so a little bit dangerous with this tool is that it overrides and removes data both in your environment and Allas environment without any asking. So if you mistype the commands, you can very easily overwrite your data or remove your data if you are not familiar how this tool works. And the default configuration at CSC is set up so that rclone uses Swift protocol, but actually you could configure rclone to use S3 protocol too. But here in these examples, we are using only Swift protocol. And then there's another toolkit, which is the atools. And that is a kind of a help script written at, the atools are help scripts written at CSC to provide easier access to Allas. And they also try to be a little bit safer so that they check that you are not overwriting by accident some data in Allas. So it recognizes that if you already have the dataset there, and it asks that if you are, do you really want to delete it or do you really want to overwrite it? It's mainly developed for usage in Taito and Puhti. So if you know that you are going to use your data also in your PC laptop, you might consider using some other tools. And the reason, one of the reasons is that when you are using this tool, it automatically compresses your data with a tool called Jet Standard, which is widely available in Linux and Macs, but not so very well available in Windows. So if you push your data to this Allas with a put command, it may require some work to open it so that you can read it in your Windows machine too. So in that case, you might want to use the rclone instead. But we'll check that more in detail. So how these things work. Here's a kind of one scenario or example case. Let's say that we have here in Puhti or in Taito a directory, now in Puhti Scratch directory, for example, for project 123, and you have there a subdirectory which contains 3 files, data1, data2, and data3. And to copy this data to Allas, there's several ways to do it by rclone, but here I use command called rclone copy to, and then I define what is the source of the data. It's now in local environment directory case 1. And now then I have to define where to copy it. I defined that it will be copied to Allas service and double point. And then you have to define the bucket name, which will be used to store the data. So now I say here that 123 bucket. If there is no such bucket already available in Allas, it creates that. If you have already used this bucket, it doesn't matter. It just adds the data there or overrides the data. And then you can define kind of the part of the kind of path, but actually it's an object name, part of the object name here in the command line. So now what this command would do, it would copy all of these 3 data files into 3 separate objects to Allas environment. It would name them as case1/data1txt, case1/data2txt. So note that actually there is no directory structure here, but these are just the names of the objects which are here. The name contains las, but many of the tools kind of can play or interpret the data so that this looks like a directory. And this data you can now, it's in the same format as here, so you can access it from your Windows PC also because it is the same format. While if you use the aput command, it's a little bit different protocol. So what it does is that first in the Puhti or in Taito, when you define that, first of all, you don't have to now define the target at all if you don't want to. You just say that aput and define the directory, put everything what is in directory case 1, And what aput does is that it first collects all the data here into one tar package, compresses the data with the JEST standard software, and also collects some metadata, a list telling that what data has been collected here, what was the original location, who has been creating the data set, and then pushes these two data sets to this Allas service. So now this data is no longer in such a way directly readable as this in this rclone dataset, but we have this command aget, which can then bring this data back and open it back to a kind of directory structure like this. So depending on the case, it might be easier to put the data with the rclone fashion, where you have each data set corresponding one object. But if you know that you are going to use your data in a larger sets than just one file at a time, it might be even nicer to have the data there as this kind of smaller chunks and larger chunks, which you can then pull out and use effectively. Because you can have millions of files actually in your very complex directory structure, and then you will end up in a system where you have millions of objects there in the object storage. So when you start doing this data transformation from Taito first to Allas and then to use it in Puhti, you should think that is it reasonable to store the files one at a time, one file as one object, or should you collect them as bigger chunks? Then aput is doing compression by default, but you can skip it. So should you use it or not? Many modern binary data formats don't compress too much, so it's just kind of a bit of wasting of computing time using it. But on the other hand, then text-based data formats compress very much, and then it's very useful to use compression. It saves the storage space, and also that makes the data transport faster when you have compressed the data. So depending on the case, it's reasonable or not. Then who can use the data? So you should remember that all the project members have the similar access rights to the data. So in some cases this is good, but in some cases you would perhaps want to do so that you have users who are able to see the data but not able to accidentally delete or modify the data. In that cases, you can have, for example, a system where you have two projects in the same time. You have the main project, which has who manages the data and owns the storage area there in Allas, and then you can open individual buckets from this main project to some other projects in the Allas environment, so that these users can have, for example, only read-only access to the bucket that is granted for this other project. So you can have a kind of a data manager project separately, and then a user project who has only read-only access to the data that the manager project manages there. Then you should remember that Allas is not the final place of your data. It's the data is supposed to be in Allas only for duration of your project, which can be, of course, several years or even tens of years in some cases. But anyhow, so this is not the kind of permanent storage place for your data. Then you should start thinking that what will happen to your data when the project closes. Is the data moved to some other services like IDA at CSC, or to some international database somewhere else? Or what is going to happen? This is not a kind of eternal place for your data. The data should stay here in maximum some years, but not always. And then, as you see, this system is very kind of a low-level storage system. It doesn't provide you any kind of a nice interface to manage your data or do kind of fancy data management tricks. It just allows you to put in data sets with name tag used labeled on them and store plenty of data in that way. But you have to then yourself keep track of the data, what you put there, and think that how you manage the data, and maybe build your own data management system based on this storage space which is available for you in Allas. And just a reminder, so Taito will be closed after 42 days from now. So you start migrating your data. We don't have too much time for that. Now, we have just opened, last week we opened this data mangler, which I'm going to show you soon. It's a kind of extra server which is linked to the Taito disk environment and which has a faster connection to Allas than the main Taito nodes. So you should use that for moving your data from Taito to Allas. The data transfer rate in practice is something like 50 megabytes per second or even less, can be up to over 100 megabytes per second also. But anyhow, you should notice that if you are having a terabyte level of datasets there, it will take several hours or days to move your data from Taito, especially when everybody else are using the same channels in the same time. So be prepared and start working with your data and be active to CSC to ask questions if things are not working as you think, because we should get these things done within a little bit more than in a month. So let's now see how this thing actually looks like. How do we use Allas? So I have now here, I have logged into this data mangler. So it's, well, I can log it out and come again. Address is data mangler csc.fi. I go in with my CSC password. And I'm now in here. And if I type here, I can actually see the same disk environment as I would see in Taito. So the same data is visible here. I'm now in my Taito work directory. And to start using Allas, I first run command module load Allas. And after that, I run command Allas conf. It asks my CSC password again. And then it lists the projects that you have at CSC. The nice thing here is that I have only the project numbers here. If I have plenty of them like I have here, it's pretty hard to remember which one was the project that I want to use. So I probably have to go to this my CSC projects list here to check that, okay, this project number, this one was this Elixir project was this one. Okay, so you have to do that in the beginning. We hope that we will someday have a kind of better information here telling also the kind of description of the project. So now I choose, for example, to use the number 4 from the list. So I type here 4. And now I have connection to this project. So I can, in one session, I can have connection to only one Allas project at a time. So I can read and write now data to this project. And then let's have a look on the tools for using this. So here is the Allas, I go to data, Allas object storage, and click this topic here, and I will have my Allas manual open here. Let's first check rclone. I can a little bit increase the size here. Rclone is a tool that contains many functions. This is just a small fraction of the all function of rclone, and you can check how some of these works from the rclone homepage. So typically it's so that you type rclone, then some copy and source and destination. And for example, to copy, okay, let's just use this in practice. So I have here a directory called webinar. So this is in Taito and in data mangler in the same time, which contains a directory called genomes, where I have some data. For example, zebrafish genome indexes for bowtie 2. Now, if I would like to upload these index files to Allas, I could do it with rclone copy2. Then I define the source where from I'm going to copy the data. from genomes, zebrafish, and then the place where I put it, Allas, and then I have to define the bucket where to put it. I now put here, I'm using project it was 136 genomes, and zebrafish. Okay, now I have the command here, and what happens is that, let's see if it works. Oh, it doesn't tell me anything because I didn't tell it to tell me anything. It's copying the data all the time over there, but it's not reporting anything to me before it has done the copying to the end. I will now interrupt this thing actually and put here -p, minus capital P, which shows me the progress of the copying process. So now it's importing data to Allas, and it's actually pushing several files at a time there. And transport rate is something like 80 megabytes per second. And it takes a while before all the data is transported there. The question is how to Puhti decompress jet standard files after transferring the data from Allas to Puhti. Yeah, the aget command, which I'm going to show soon, will do that automatically for you. So now I uploaded the files there, and I can now list this stuff in Allas. If I use command rclone -ls, I take actually lsf here and define the place which I want to list, and it now shows me that here I have the files. And actually I will now show you also another view to the data. I'm using the Puhti web interface here, and here I can, I put it a little bit smaller, this one. If I now refresh the view, I see here the bucket which was created by the rclone command, and here I have the zebrafish as a directory, and I have these files, and I can now download this file, and it would now go to my personal laptop here if I would do it, or I could upload with this button a file from my personal laptop to this Allas bucket here. Okay, so this is the way how you do it with rclone, and then in the Puhti you would do the opposite. You would just, let's do it. Okay. Well, I won't do it now, actually. You could just use the same command here, but opposite order. Say that copy this file, for example, this one. I will now copy it to my local directory here. So it will bring it, oh, it's this directory, okay. And now the data is copied back. So I could run this command also to Puhti to get the data back from Allas there. And now I have this thing called test, and which is actually the file which I copied there because I named it as test. So this is the rclone. It has many other features too, but it's very effective, but it doesn't ask too much, because if I run the command again, now the same command, it just gets the data again here and overwrites it if there's some difference, without any asking that, hey, there is already a file called test. Do you really want to override it with the dataset that you are copying from Allas? Then the other toolkit which I'm going to demonstrate is the A-tools, created at CSC or built on top of the rclone package. And here we have a kind of predefined scripts for importing data to Allas, listing data in Allas, publishing data in Allas, and downloading data from Allas. So now I put the data so that each index file, each part of the index files was as a separate object there, but actually I probably will always need all the index files in the same time, so it's no point of having them as a separate objects there in the Allas environment. So what I could do now is that, for example, I could just go to the genomes directory, and now if I put here command a put zebrafish, what it does is that it collects all the data there in the zebrafish directory into a one package, and then pushes it to Allas environment. I hope that this doesn't take too long, because of course packing and compressing the data takes some time. Nearly there, I hope. So now everything is now collected to one chunk here, and now I put this one compressed file to Allas, and as you can notice, I didn't define the bucket at all. So one of the features of this aput and aget commands is that they try to reflect the directory structure in Taito and in Puhti, so that it checks that, okay, I'm now running. Yes, you can also specify bucket in aput command. I will show that next. So by default, this kind of checks that, okay, now I'm in work directory. So it creates a new bucket, or if it doesn't already exist, use existing, it is there, which is named according to the user and the project that is used. So it's listed here, but I can use command a list to see what is now in my Allas project. And now there were new bucket created, which is my user account, the project I'm using, and then Taito work, telling me that this is the default place where the stuff from Taito work will go. And if I put here a list and this one, I can see that there is one object which is called webinar genomes zebrafish. So also in the object name, I have kind of preserved the location in Taito work that where this data was. So now when I would like to use this in Puhti, what I would need to do is to log into Puhti. I go to, let's see, to my Scratch directory for certain project there. And if I now type here the same commands, module, module.allas, allas.conf, and notice that I here now must define to use the same project which I used here, otherwise I don't see the data. It takes a while before it checks what projects I have available. I could also define the project here if needed. Yes, there were questions about the webinar slides, but actually I will point you up to the tutorial instead of this slides, because that's better for you. And so I now define here the number 4 that I use the same project. Now the connection is open for 8 hours. If I now take the same a list command that I used here in data mangler or in Taito, I can see the same file, and if I make a directory called webinar, and then type command a get, and this object, this one, the whole thing, then I will get the data now to Puhti from Allas, and it's now available from there. You could also use this aput command here so that you could just, well, first of all, you can define with -b that I would now put here 136 zebra. Define the bucket name separately if you want to. You can also add here, not actually in this case. You can also, if you are uploading individual files which are already compressed, you can then use --nc coming from no compression to upload the file as non-compressed dataset to the Allas environment. So this would now put the same data to another bucket. So if we take a view of the data, once again here in the Photo web interface, I go back to the containers list. So now I have here the workgrid container I just created, and then I soon should have the zebrafish container, which is, or bucket, which is created here. So here they call the buckets as containers, but we try to use a CSC terminology so that these things which are here are called buckets, because this term container is used also in other meanings in computing nowadays so much so that we don't want to confuse the Docker containers or Singularity containers with the data containers we are discussing here. So now also this upload has been done. We can see that if I refresh this guy here, this view, we will now have also the Zebra bucket here, and I can see also the data here. What you see here is that now actually two objects were created. So this is the main object that I uploaded, and here is the a meta called object, which is the metadata file that is created by a put command. So this is not created, this won't appear when you are using rclone, and as this is kind of extra stuff, the a list doesn't show this at all. Also, if you, I will show you the listing here again. If you check the container list for your project, what you might have there. For example, you might notice that there are these things called some bucket name underscore segments, and these are the places where the large objects are stored in pieces, and you should not pay any attention to these guys, these segment buckets, because you have your front object here in the main bucket, and you will use that, and this is just for storing the pieces of your object automatically and retrieving the data back from these places. So this is not something we should use interactively yourself at all, but let the user interface, the command line clients, use these things, and don't mix these segments directories at all, and don't delete them or don't try to modify them. Just let them be there if you see them. Yes, that was most of the stuff. The one thing I could show still more is that, okay, when you are starting to push on your data, for example, I would now have here this directory genomes, which contains 3 genome sets here. If I would go one level lower here in the directory tree and start uploading this command with a put command, I could just put here genomes, and then it would collect all these 3 cases into a one object. First tar it and then push it to the environment as one object, but it might be more reasonable to create 3 objects of these things. So I would put here star, and it would allow me to put each of the put the stuff there, and I will do this example. So there's a question that how can you manage when you have just 1 terabyte of storage space in Puhti? That's not enough. Well, that is certainly not enough for most of the project. The idea is that you apply for more space there, but it is not permanent space. We just want you to recognize that you have to first think how much space you need there, and then you get the space, And another issue in Puhti is that if you apply, and yes, which I haven't yet mentioned, but nowadays in this new environment, both in Puhti and in Allas, storing of the data for larger amounts than what is the default starts consuming your billing units. Not much, but a little bit anyhow. And the idea is that you are kind of aware that you have some data in the CSC environment and you have to react every now and then by applying more billing units and explaining why you still have the data there available. And the billing is based on different features in Puhti and in Allas. So if you get in the scratch area, if you apply for larger quota there, we will be billing you based on the quota that has been granted to you. So not based on the actual data you have there. If you have applied for 50 terabytes of storage space in scratch area, then you will be charged for this 50 terabytes all the time, whether you have any data there or not. While in the Allas side, if we grant you a 50 terabyte area in Allas, we will be charging your billing units only based on the data that actually is there in Allas. And further, the billing is the Allas storage space is cheaper than the scratch area in Puhti. So we try to kind of guide our users to use more Allas than the scratch area in Puhti. Then there's one question: if you can modify your project name in Puhti. Depends on what you say about the project name. If the project underscore number or something like that is fixed, that you cannot modify. But of course, there's a description of the project which you can then modify in the My CSC environment. But you cannot kind of change the name of your project which is shown there in the Allas commands or in other ways, other places there in Puhti environment. There's a question that should we install software in ProApple and save data in Scratch as a rule. Yes, that's how that's the kind of plan how you should use Puhti, so that if you install some software, you use ProApple for that, because that's an area which is preserved. It's not automatically clean, and then your research data is in Scratch while you are working with that, and then when you are not working with that, you copy the imported parts to Allas, and then when you continue your work, you pull the data from Allas back to Scratch environment. And then there was this question about how to get the slides or some other examples how to use this system and do the migration. So please study this manual. Not this one, but go to the Allas-object storage. There's a link also from this area, to this place. And here you will find these tutorials, especially this using Allas to migrate your data from Taito to Puhti. Here we have tried to collect some examples how you maybe could be doing this data transfer, so transfer process from Taito to Puhti. So here are examples for both APUT and ArcLoan in a different kind of scenarios, just kind of a lightweight, easy examples. And then if you have large files, or if you have a large number of directories and individual files to be copied from Allas to Puhti, you can study these ones. And note that this Allas environment in general is still much under construction. So even these tutorials are changing all the time. Check out the systems from here, and if you have any questions, contact CSC, because we are still building this environment while you are in a hurry to start moving your data away from Taito, because after 42 days, Taito is no longer available, and by that you should have your data saved somewhere else. Is there any other questions still? Oh yes, the HPC archive. Yes, HPC archive will be closed also at some times, but it will be not closed in the same time as Taito. It will be available also in next year, probably through the data mangler nodes. That's not sure yet, but anyhow, somehow it will be available. Don't worry so much about the HPC archive at the moment. Please focus on the data that you have now in Taito. And if you about HPC archive that much still, that don't put any new data anymore to HPC archive, but in the future use Allas instead. How about setting up the connection to Allas via CyberDuck? So that's discussed here in the Allas object storage if you go to the manual. And then you go to CyberDuck, and it's pretty easy to take it in use. So you have to define the project name and the username here in the tenant access key. So in my case, I was using here something, it was project underscore 2,163. So I would type it here, then double point and my user account, and then my CSC password here. Make sure that I have port assigned here and port number 5001 here, and then it should do the connection. Then there's a question about what happens if data transfer with ArcLoad takes more than 8 hours. The connection must be valid when you start the data transfer process. So if you have one big file which takes long time to transfer, that will go to the end. But when you looked at, when we did the ArcLoad here with the, if I do the ArcLoad here to, let's say, if I do the ArcLoad command so that I take the whole genomes directory and start copying this one to this genomes bucket here. Now it will start copying several files, as you can see. And each of these copying processes, which is happening here, requires its own connection opening. So this process would, if you start copying the whole your, say, project directory or work directory in this way, this will continue for 8 hours. But then it's not able, after 8 hours, if some files are still left to be copied, it fails to open a new connection, and the copying process cannot proceed further. So it will continue running until it reaches the 8-hour limit, but after that it cannot start new ones. If you have already started to connect the copying process, then it can continue forever if needed, but it cannot start new copying processes anymore after 8 hours. And this to avoid this thing, you can kind of either use for loops or a put command in the way that is described here in using Allas in batch jobs, which discusses things that, okay, how do you cope with the situation? For example, in the batch jobs, when you don't know that is your connection still valid when you actually need to do something with the A commands or with ArcLoad. And in that case, the key issue is that you have to do the configuration with option -K, and then either use A commands or then with ArcLoad add this kind of script command set up here, which refreshes your connection to Allas when you need to use the ArcLoad command. Okay, any other questions? We are already on overtime, so I guess we have to end, but please contact CSC if you have any questions or you want to have more information about how to do the data migration. This is the kind of one of the most important topics for CSC too for the rest of the year. We want to help you to get your data safe before we have to close down Taito. Thank you very much.